So let's take our first crack at how to graph a function when you really have no idea what the thing should look like. And the example that we're going to take is some simple polynomial in two variables that's nonetheless sufficiently complicated that I would expect you to have no idea what this looks like. I mean, I certainly wouldn't be able to sketch the graph of this just by staring. I'd have to get my hands dirty. So we're going to do this by traces. This means we fix the value of one of the variables to reduce it to a single variable function and get an idea of a curve. And then after doing that for a few curves, we can put the curves together. So setting x equal to 0 means I'm looking at f of 0y. So putting x equals 0 in the formula gives me y cubed over 4 minus y. And so now I've got a function of a single variable. So I can use calculus and I do a little deal, and with some investigation with derivatives and whatever, I can work out that it's going to be some function that looks like this. The precise intercepts, I don't really care about. I just want to know it's a cubic and it's increasing in the positive x direction. It's good enough for now. Let's look at another slice. So let's fix x equal to 1. And so now I've got y cubed over 4 minus y, and now minus a half. Okay, so that means I've got the same picture as before, except that now it's shifted down by a half. So I just slide it downward. Oh, there we go. All right, and so you notice that x appears in this formula with a square on it. So if I were to do the slice for minus 1, so minus 1 here, it would actually look exactly the same. So that's cool. So for plus or minus 1, I get the same slice or the same trace. So now I can try putting some of these together. So the idea is that from this point here, I can make the observation that each of these traces with a fixed value of x is a cubic shifted down by x squared over 2. So that's enough to tell me some idea of what's going on. So let's see. So let's draw the axes like this and like this. So here's x, here's y. And so now if I look at the slice at x equals 0, so here's where x equals 0 takes place. Then in this plane, and the plane I'm talking about is the xf plane, then the cubic looks like something like that. Okay, now if I shift forward to this, I didn't like that, to this one right here, so this is where x is equal to 1, then I would take this this same curve here, and well, first I would make it green because I'm going to put it in the green plane, and then I would slide it out on the x direction by 1. So that's where he is. But then over here, he's shifted down by x squared over 2. So let's drop him straight down. Boop. So it looks something like maybe that. You notice I'm not being real precise. I just want to get a qualitative idea of what's going on here. So just a general kind of idea. Okay, so now if I go back here to x equals minus 1, then I'm going to have the same curve, right? So if I slide this plane back to minus 1 and then move the curve down while inside that plane, but to about the same amount, then I have that. Okay, so that's enough now to get me some idea of what this is looking like. So as I come forward and backward, it's going to be going down this way and that way because of that minus x squared. And so I've got some sort of a surface starting to come together here, and I can draw some of these curves that are going along some of these like this. And presto, voila, I have the surface coming out of that. Maybe you didn't like that. Maybe you're like, for the example that you chose, doing the X traces turns out to be absolutely gummy. Then you can do traces the other way, right? So let's look at like the trace where y equals 0. So then we've got f of x0 is equal to minus x squared over 2. All right, so that's going to give us a downward opening parabola like this. All right, and what if we did y equals 1? Well, then we have, let's see, so now we've got 1/4 minus 1, so that's going to be minus 3/4 minus x squared over 2. So I'm going to have shifted down the vertex of that parabola, and then of course all the rest of the parabola as well. And if I were to put a minus sign in front of it, minus sign, then this would actually change to be positive, and I would end up with a curve up here as well. And so now I get an idea of what's going on. I can make the mental observation that the curve is a parabola that's been shifted vertically according to that cubic function. So let's see what we're going to do with this now. So I'm going to start off. I'm going to have that in the y equals 0 plane right here. The intersection of the graph with this plane is going to be this parabola. So let's see. So there we go. And so now if I shift to some y equals 1. Oh, I forgot to label that first one. That was the y equals 0 plane. So if I look at what's going on in y equals 1, come here. Then let's see. So I take this guy and I shift him out to y equals 1 and then down by 3/4. And similarly, if I look at the minus 1, so just slide it back here. Oh, I need to give him a minus sign, minus 1. Then I get the same thing as if I'd taken this parabola back and then pushed him up by 3/4. And it's going to follow the rise and fall of that cubic function. So as I go even further, it's going to start sinking back down, and then much more down. And if I'd gone backward in the, if I'd gone forward in the y direction, it would have started to perk back up again, and gone even further up. And hopefully this starts to make that same figure that we saw a moment ago. And just for confirmation, I can plot out on a computer. Ta-da! There it is. Okay, so that's the essence of graphing by traces. The next thing we'll look at is, instead of fixing the value of an input variable like x or y, we'll fix the value of the output value of f.